Alright, so what have we got? We have a hockey ball of 150 grams. And what is this? It's hit by 2 hockey sticks? Okay, let's see what's happening. So suppose we have this hockey ball over here. So shade it in. And it hit by a force of 15 newtons north. So we have an upward force. Actually, before we even do that, let's just make our directions very clear here. We're going to say that, oops, draw some straight lines. I'm going to say up is north. We're also going to say that up is positive, going to the right is positive. Okay, so from here, let's draw some forces on our hockey ball. So we have an upward force going north of 15 newtons. We also have a force of 20 newtons going in the east direction, so to the right. Okay, so it's determine the acceleration of the ball and the direction in which it travels. Well, if you want acceleration over here, then what we need to find out is the net force on the ball. So let's find that out. So the net force, if you have something like this, remember that these are at right angles to each other. And so the net force is really the addition of these two vectors. So if you were to redraw these out, what we really have is vector of 15 going up, vector of 20 going to the right. And if you add two vectors, remember, from tail, and then connect the head and tail of the two vectors, and then the resultant vector will be from tail of the first vector to the head of the second vector. This is your net force. And this net force over here will be equal to, let's have a look. I'm going to use PyFac here. So we're going to get 15 squared plus 20 squared. This looks like a Pythagorean triad, but we'll just confirm that this is 25 using our calculator, not our screen capture. So square root of 15 squared plus 20 squared is equal to 25. Okay. Oops. 25 newtons. Okay. We also want to know the direction of the ball. Now, if it's accelerating, if the force is going in this direction, then it follows that the acceleration of the ball is also going in the direction of the net force. So what we can find out over here is the true bearing of the direction of this net force, because this will also give you the direction of your acceleration. So to find out what this angle over here is, because this is already the true bearing, it's the angle from north going clockwise. So just as a separate piece of working out, we have, let's see, before we begin, trig ratios. We've got opposite and adjacent. Of course, you can use 25 here as well. That's fine, but since we're given 15 and 20 at the start, I think we'll just use tan theta. Not 15. It'll be opposite on adjacent, so 20 on 15. So theta is the inverse tan of 20 on 15. So going back to our calculator, let's find the inverse tan of 20 on 15. This will give us 0.93 radians, or about 53.13 degrees. I think I'm going to use that in physics. Just keep it to the degrees format. 53.13 was it? Okay. And this is our true bearing as well, because it is from the north direction. So what's happening here is that the ball is traveling 53.13 degrees from the vertical from clockwise. Okay, and we haven't fully answered the question yet. We got the direction over here, so this is okay. Direction is just over here. the acceleration of the ball. So the acceleration of the ball depends on the magnitude of the force. And just finishing off the question here, we can use Newton's second law to help us work out what that is. So if the net force is 25 newtons, we know that the net force is equal to mass times acceleration. And from the start of the question, we knew that m was 150 grams, which is of course 0.15 kilograms. Okay, so if you want to find the acceleration, then this is simply the net force on mass, which is 25 divided by 0.15, and this is equal to 25 divided by 0.15. Yeah, let's get a decimal. About 166.7. Oh, that's not good. 166.7 meters per second squared, approximately. And so we have the direction over here. And over here, this is the magnitude of the acceleration, the size of our acceleration. So remember that all vectors have a scalar and a direction, and so of course the direction was referring to the true bearing angle, and the scalar is referring to the magnitude over here.